Welcome, everybody. Tonight we're working on our Unit 8 exercises. These exercises focus on sets and dictionaries. I have 5 different exercises from the book to complete. I do want to point out that aside from just the normal exercise description document, which I have here on the screen, I just had it up just a moment ago, there's also this text file that we'll use for one of the exercises and this old Python file that we'll use as a basis for building one of the other programs. So make sure that you do a right click save as on these. So these will be data files that we're using basically to kind of augment what we're doing. Going back to the exercise description, let's look at this very first exercise. And this one says, write a new version of the program int name pi from chapter 5 that uses a dictionary instead of if statements. Okay, so we need the starter program to be able to do it. That's one of the 2 that I did download. And so what I'm going to do here is I'm going to find that in my folder, which is here in my downloads, and that raw data text file. I'm going to highlight both of those and I'm going to cut them, and then I'm going to add them to the folder where I'm going to do my work. So let's basically start with a little bit of file management here. We are working on Unit 8, so I'm going to make a Unit 8 folder. I'm going to paste both of those files in. Now I'm going to go ahead and launch my IDE, and let's go ahead and launch Spider. So we'll do our work inside of Spider here tonight. Give that a moment to launch. And then once Spider's up and running, I'm going to take a look at that file and then figure out what I'm going to do to convert it to using dictionaries by looking at what it's doing now, right? Before I can convert it, I have to understand what is the working paradigm for it as it is. All right. All my old files are open here, so I'm going to go ahead and do a close all command just to get them all off the screen. And then instead of creating a new file, I'm actually going to begin by looking at that file that I downloaded, which I put into my folder. And I just have to know where I put it. So I just got to go find it. And if you guys remember my whole pattern of getting here. All right, so here's the program, and I'm going to zoom in here. And this is one that's kind of interesting, and I'm not sure that I assigned this one to you guys, and if I did and I forgot, I apologize. Code becomes a blur after a while, but basically what this program did is it takes an integer that you type in, and then depending on what number you type in, it takes the number and converts it to words, right? So like if I type 1,457, as a number, I would type that number in, press enter, and then it would bring it back to me as words, right? And the way that it worked basically is I would get the value from the user, I would store it, and then I would send it to a function that would process it. And what I basically did is I figured out how to take the number, do some fancy math, right, with if statements, like if it was a certain sized number, and then I could convert it to the correct words, right? And so, for example, right, if I entered a number, it would send back words like this, like 274, right? And these if statements would basically handle the transition. And I want you to notice that depending on how big the number was, right, it would trigger some code, and then it would take part of it and send it to another function, which would check the digit that we're sending it and then either return like a base level number, right? So these would be digits. These would be the teen names because, of course, 10 through 19 are weird in the English language, right? Like some of them, like most of them say teen, but there's those 3 that don't, right? And then all the other 2-digit numbers, 20, 30, 40, 50, 60, etc., right? And notice how many if statements we had to write to make that happen, right? So you write this code, you do some fancy math, call a bunch of functions. Each function takes the number or numbers that you're sending to it, and then runs an if statement on it to return some text back to the rest of the program, right? And just to demonstrate to you that it does work, right? Let's just go ahead and run this, and you can run this on your own system, of course. I'll just put in, like, I don't know, something like that, 345, and then it comes back with the correct number, but as English, right? And I mean, it's pretty simple program in some ways, but there's a lot of if statements here, and there's a lot of logic that goes behind kind of doing this. And you can see, it took what, like 80 lines of code to make it happen. And granted, there's a lot of comments in here, and all that, but it's kind of a nice little program, right? But it uses if statements. So what we're going to do is we're going to take some of this logic, we're going to borrow it, and we're going to use basically, I think it said to use a dictionary, if I remember right. Let me just kind of go back to the instructions here, because frankly, I forgot already. Yeah, we're going to use a dictionary instead of if statements to help the program find the correct value names, for all of this. All right. So let's go ahead and start to kind of logic through this a little bit and figure out, like, what is the procedure for making that happen? All right. And I'm going to begin. I do have a blank file here, and I'm going to borrow some stuff here. Okay. And, for example, it's still going to do this task. So I'm going to copy that comment, and I'm just going to put it at the top of my program, just so that somebody that looks at it still knows what I'm doing. Right. I'm going to go ahead and do a save as right off the bat, and you should too. So we can save our work here and then put it in the spot where you normally put your work. Like, you can find it basically later. So this one is exercise 8_1. All right. All right. Now, the previous program, when we look at it, I did have a main function, and all the main function did, and mind you, this really simple main function, is it gets input from the user and then calls a different function, which puts the name on the screen. And that's kind of the whole program from the main program standpoint. I have no reason not to borrow that. So I'm going to copy that code verbatim and take it to my new program here. And I'm going to put it here. I'm leaving a little room at the top, and you'll see why in just a moment. And then, just so I don't remember, or don't forget, I should say, to call it, I'm going to run the main program by just putting a call to it down here at the bottom. Okay, so please make sure you go ahead and do that. Now, all right, so it's saying that it's looking for this function, and I don't have it yet. So I think that what might be wise is that we go ahead and borrow the name of that function for now, right? And I'm just going to copy that and bring it over here to my program. And actually, I'm going to copy the description for it too. So I'm going to copy this part of it, and you guys can do the same. You should have the file available to you. So I'm just going to put in that descriptor of the function, and then inside the function for now, I'm just going to put in a pass so that it doesn't throw errors. Okay. Now, up above here is where I'm going to define my dictionaries. And what I'm going to do here is, rather than have this big collection of if statements, I'm just going to simply have values up on the screen in key value pairs, where I'm going to take a number, make that the key, and then the word that goes with it is going to become the value. And, if you look at the previous example, we have some code here, basically, that once again, we're going to borrow, right? And so I'm going to talk about why I'm borrowing it, because when somebody will put in this prompt, right? Please enter a positive integer less than 1,000. So between basically 0 and 999 is what we're looking for. And that will get stored in value, and then value will get sent to this int name function, which we've already mimicked. And then these two lines will come into play. Now I'm going to borrow these two lines, right? And you should do the same. And then I'm going to put them here inside int name. And then notice, let's take a look at what this is doing. The number that the person typed in will be sent through this value variable. It'll be received by the function, and then the function will take it and store it here in a variable called part, right? And part is a thing that's going to kind of carry through this function, and we're going to mess with it. Now, the reason we're putting it into a variable is so that we can leave the original value unaltered, basically. Secondly, we create a variable name, which is an empty string, and then we're going to use that string to collect all the words it takes to put something like this together. So it's going to store that as a string, and that'll all go in name. And then when we're all done with it, we're going to return name as a string, and it'll be the whole thing already built, right? That's kind of our goal. So this remains the same as from the parent program. Then we go through this logic, and I think this logic is really fascinating here. I am going to be tweaking it, right? We're still going to use some if statements. So I'm going to borrow all of these if statements, and I'm going to bring them over to the program, and then we're going to start to do some alterations to the strings or to the if statements. And then ultimately, when we're all done with this stuff here, we are going to return. And notice I'm coming back to the indent point here, so everything lines up. And I'm going to say return name. That'll be the end of this. Now, this is throwing a bunch of errors because right now we're calling on functions that I don't have. These are not functions that exist in my program, and I'm not going to create them, right? We don't need to. If you look at the original source program, digit name, tens name, teen name, digit name, these are all functions that each have a whole bunch of stuff going on too. And look how many lines of code that occupies, like 40, 50, 60 lines of code, right? So those are going to go away in our new program, but we have to re-engineer the stuff. And instead of doing this here, where we're going to do a function call, instead what we're going to do is we're going to borrow these names and build dictionaries out of them. So follow what I'm doing here. These errors will eventually go away, but we're going to create the data structure first, then we'll come back and fix this code, and then we'll pretty much be done. So the first thing that we'll do is we'll create a function called digit name, or excuse me, a dictionary called digit name. I'm going to put it way up here at the top. All right. And I'm going to put in an equal sign, and I'm going to start with a pair of empty curly brackets. Then I'm going to create another dictionary called, I'm going to start with teen names. I guess it doesn't really matter what order you do this in, but I'm going from digits to teens to tens, and you'll see what my logic is here in just a moment. So here's another one I'm creating that's basically empty. And then, of course, we'll create tens name also with curly brackets. All right. Now, interestingly, until I put something inside those curly brackets, any one of these could become either a set or a dictionary, because think about this, sets and dictionaries both use curly brackets. It's the data I put inside that defines whether it's a set or a dictionary. Dictionaries have key value pairs, sets have singular values that can't be copied. So what we're going to put in the digit names is we're going to basically proceed like this. I'm going to put in a number like the number 0, right? So when I think of the digits in a base 10 number system, they're basically 0 through 9. The first one, just like the index value, right, is a 0. So I'm going to put in 0, and then I'm going to put in the text 0. Then I'm going to, after the double quotes, I'm going to put in a comma, and then I'm going to say 1 colon, and then I'm going to say the word 1, right? And the comma goes after the double quotes. And then basically you just continue that until you get up to the number 9. All right. So I'm going to do a little bit of copy paste, right? To speed up my process here, you guys have to go through the laborious process of typing it. Right, there you go. And I'm going to do something kind of weird here that we don't usually do in Python. Usually when we write Python code, we're not allowed to take the code to the next line. We just have to keep going off to the side, right? And if you turn on your word wrap, it kind of fixes it. But there is a continuation character that you can use inside of a data structure like this, which is a backslash. So if I put this backslash at the end of the line, I can now continue this dictionary on line number 2. And you'll see why I do that. So I'm going to get the rest of the numbers in there and then paste them right here. So I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And this is all the single digit names, right? So the last number in that number that we'd be typing in. All right. Now we'll switch to the teen names, and the teen names will look like this. This will be the numbers from 10 to 19. So the first one, of course, would be 10, right? And so for that one, we'd type 10, right? And then we come outside there, and then we'd go to 11, and then, of course, that would be 11, etc. And once again, with the magic of copy paste here, I'm going to put in a few more, including the continuation character. And then I'm going to put in another line, and then one more line for the rest of them. So we're going all the way up to 19 here, folks. And then just take your time and type that in. I'll try to be patient with the process here. And if need be, maybe type it up over the break. All right. But you see how the name corresponds, right? So like all the numbers from 10 to 19, those are the teens, right? And then after we get past the teens, then we kind of go back to normal and we say 21, 22, 23, and then 31, 32, etc. And so once we get past this point, then we do the tens. And then, of course, you can probably figure this one out too. And you can do this in any order you want. So like your normal order would be like to start with 20 and then count up to 90. But for whatever reason, I'm looking at how I did it last time and I went backwards on it. And I think I did that to make a point, right? That the stuff doesn't have to be in order inside the data structure, because really how you identify the piece of information in the key value pair is with the key, right? So if I look up 40, it's going to give me 40. It doesn't matter what position it's in. It's not ordered in any certain way. So with the first two, I went from smallest to largest. With this one, I went from largest to smallest, and ultimately it doesn't matter. Okay. So take your time and get this all typed in. These are our data points, and I want you to notice that I'm placing these dictionaries at what we call the global level inside the program. So it's above the main method, right? But that means all the methods inside of the program, including the main method, can access this information. All right. Another thing you should put in your head is when we're working with dictionaries, can I change the values in a dictionary? And the answer, of course, is yes, if you want to. As we're going to use it here, we're not going to really change anything, by the way. We're just using these as a lookup, right, for a value. So instead of like this previous program, when we got to these inner functions, let's call them, where it's like, if the number is 10, return 10. If the number is 11, return 11. If the number is 12, return 12. Instead, we're just going to look it up in a dictionary. So here's 10, here's 11, here's 12, right? And we don't have to say if, and all that other gobbledygook. It's a lot more efficient, is basically the point. Right. Now the trick is to get the logic below in the if statement to convert all the code to what we need it to be. And this is like painfully simple to do. And I want you to watch what we're going to do here, because before we are running a function and sending a value to that function, and then it would process it. And just to kind of get you to understand what was going on here in the original program, if I got a number, and let's say I typed 145, that's greater than or equal to 100, correct? Yes, right. So this if statement would be true. I would come in here and I would take that part, right, that number, and I would do what we call integer division. Now, integer division is the flip of modulus, right? So when I do integer division with two forward slashes, I'm only getting the whole number amount of which goes into the number. So think about this. If I typed in 145 and I do integer division 100, how many times does 100 go into 145, excluding the remainder? Once. If I typed in 273, how many times does 100 go into 273? Twice. So that's the number I would get. So that's why we get the digit name, right? So if I got 100, 200, 300. So that's what was going on here. The function would convert it to the right number name, but I don't need to do that, right? I don't need to send it to a function with a bunch of if statements. I still want to do this integer division, but instead, what I'm going to do is I'm going to convert these parentheses to square brackets. And so what's going to happen here is this will still resolve to the same number. So let's say I put in 273. This will resolve to 2. Then it will go to the dictionary called digit name here, and I'm changing it in the wrong spot. I should be changing it on this program, but it'll come up here. It'll find the number 2 and then return it to that spot. So basically what we do here is we convert these to square brackets, right? And square brackets are the ways that we extract things from a data structure. So we're going to the dictionary named digit name. We're looking up the number that's calculated here, which will be 0 through 9. What's going to got to be one of those, right? And then returning that text and then concatenating it with 100, storing it in name. Then notice what happens after that. Then we do modulus. Okay, so think about what happens. I divided by 100 and I got the whole number amount. Then I have a remainder, right? I do the modulus on the same number. So I take 273, mod it by 100, and what do I get in that situation? Well, the 2 is taken away. We're not looking for the how many times it goes in. We're looking for the remainder. The remainder is 73. So now inside of part is the number 73, and we move on and we say, if part's greater than or equal to 20, which in this case it is, then we look up the tens name, right? And what is left over? Yeah, and this is where we might have to tweak our math just a little bit, right? Because I can't take 73 and look it up on this list. What I could look up is in the tens name, I could look up the number 70, but how do I do that mathematically here? Well, first thing we'll do is let's get rid of this stuff, right? And we'll change this to square brackets, right? And then we'll think about that. So the numbers coming in is 73. If I mod it by 10, think about this, it will give me what as a response. I'm sending the number 73 to it. So I'm not, and I apologize, I'm not modding it, I'm integer divisioning. This, so 10 goes into 73 7 times, right? But I want to look up the number 70. So then I have to multiply that result by 10, right? So this is the calculation. First, I do integer division to get the whole number, and then I multiply it by 10 to turn it from 73 basically into 70. And then that I can look up in tens name as a 70 and pull back the correct text, and then append that to the current version of name. So now I have 270, right? And then the next part of it is once again to mod this time by 10. So I take 73, mod it by 10. I'll have 3 left over, right? So 3 carries forward, and then I check to see else if this part is greater than 10. And if it is, like if it was 11, we'd look up the team name if appropriate, right? And in this case, it wouldn't be that. But if it was, let's say it was 10, 11, 12, 13, 14, etc., we would just basically look that up in the chart and then convert it to the right name, right? So that's not going to happen every time, right? Only if it's in the teens range. Otherwise, most of the time it'll be above 20. Right? Once we get past that, part then becomes zero. This is really kind of weird, right? So it's either going to be the three or the zero. And if the part happens to be greater than zero, right, it's going to be a number between 1 and 9. Then we look up that name in the digit name table. And once again, we just convert this to square brackets to do that. So look up that number there and then pull back the name, append it to the string, and then we're all set to basically output the string. So that's the revised code. And so, like, this is kind of the weird lesson in this, right? We went from a program that had, granted verbose comments, 82 lines of code, to a program that only has about half as much and does the same work and arguably more efficiently, kind of using the same logic. There's still some if statements here, and we still have to do some modulus and integer division and a little bit of logicking our way through it. But all the value lookups come from the dictionary. This is a better way to look up a value than by doing a bunch of if statements and returning a string, right? It's a lot more efficient, absolutely. All right, let's go ahead and save this and run it, and then we'll take a break, by the way. So here's the runtime on this, and please enter an integer. And of course, we can, I don't know, put in a couple different ones. There's 123, right? And I think it's pretty interesting how it pulls in the data structures here, right? As you run it, and keep running it and try some different values. So 999. Try some weird ones like, I don't know, 317. So we get a teen in there. Or how about one where it ends with a zero, like 450, right? And then you can try some really small numbers like, I don't know, 2, and it works. The only weird thing, okay, that's got an extra space in front of it. That could probably be fixed, but it is working. And I think this is a really clever little program, but it shows you basically how that we can take a value and look it up inside of a dictionary and return its, or look up a key and look it up in the dictionary and then get its value, right? And right, so like anything that drops in here is the thing we're looking up. So if the teen name happens to be, 15 is the number we're looking for, this is the value it returns. So I think that's really fascinating that you can do that. So it becomes, dictionaries in a way become kind of a lookup mechanism. It is really kind of a good way to think of it, where we associate either a number or a word with a number or a word, right? That's the most common usage of it, but it can be, once again, more complicated data structures. All right, let's go ahead and take a break. And about 6-7 minute break is appropriate. I'll see you guys at like 8:58. All right. Before I hit record here, coming back from break, I did share 3 text files with my students, which are basically song lyrics from the Beatles. Simply created these by doing a quick Google search, finding the lyrics, copy pasting them into a text file, and then I'm going to use these as fodder for the program that I'm about to write, maybe a couple of the others as well. So we're going to be practicing that skill again. Going to the second exercise description here, this one says, write a program that counts how often each word occurs in a text file. This is kind of an interesting thing. All right. People in my natural language processing class, right? This is kind of like one of those things that we kind of look at, right? Like, and like how many times words occur and which words we ignore and all that kind of stuff. And as I've been saying all along, Python is very, very elegant at handling text and text files and processing language. We are creating a new program here. I'm going to save as. This will be saved as, what are we going to call this? Exercise 8_2, except not with special characters. Thank you. Let's zoom in a little bit and then let's start writing the code. And I'm just going to put in this basic info here at the top. Right, just tells us what we're doing. Um, and then we're going to basically ask the user for what file they want to input. Now, okay, I'm not ignoring the fact that we know how to do a main method. I'm not ignoring the fact that we know how to put a whole program inside of a loop and make it keep running. So if you want to do those things, you can. I'm also not ignoring the fact that we can and probably should use a try except statement when we're reading in files. I'm just telling you up front, I'm not doing any of that. I just want to kind of get the code to work. But if I was writing this for real, like I wanted people to use it, I would add all those capabilities. I would let them run it again. I would let them, I would put the read file stuff into a try except just in case it fails, maybe a loop to give them a few chances to do it, all of those things. And I'd probably run it with a main method, and I would probably do all the coding inside of functions and call the functions. I'm not doing that because I want to focus on the logic of processing the language here mostly. So first thing I'm going to do is I'm going to create a variable to store the file name. And then I'm just simply going to prompt the user to enter the name of the file. So I'm going to say, enter the name of a text file. Right? Prompt can look whatever you want it to look like. And they will type in a name, we'll store it. And then we're going to create an in file variable. This is where the file is going to get stored. And we're just going to use our open command. We're going to feed in the file name, and then we're going to open it in read only mode. Now, think about this, if we're just counting the words in a file, I really I don't need to change them, right? I don't need to come up with a new version of a Beatles song. I just want to read those words in and then utilize that in my program. We're going to use a dictionary to store the information, right? And so, because I'm going to be basically doing this, I'm going to be going through the text file word by word, line by line, and really I should say line by line, word by word. Every time I hit a new word, I'm going to go, oh, this is a new word. Let's add it to the dictionary. And then every time I encounter that word again, I'm going to count it. Right. And that's kind of the procedure. So what I'm going to do is I'm just going to form a dictionary and I'm going to call it counts. Why? Because that's what I called it last time I did it. And I'm looking at my solution from last time. Right. You got a better name, go for it. Right. Then we're going to get to the processing part here. Oh, that's not what I wanted to paste there. Let me try to recopy that. I have a little comment here. And I want you to think about what happens when we read in a file. A file, a text file. And you know what? Let's take a look at one of our text files here. Let's take Hey Jude, for example. So this is opening up, of course, on my other screen here. And there's the words right there. More words than I thought were in that song. There's a whole lot of na na's, yeah, yeahs, right? Which the Beatles do quite a bit. But you notice how many times they go na. I thought that would be kind of funny to count that, basically. But notice like the nature of how a text file is put together, and that is a line of text. Then there's a carriage return, which moves us to the next line. And then each line of text has a word, a space, a word, a space, a word, a space, a word, a space, etc. And we've learned from previous units that when Python processes a text file, we can read through an in file one line at a time. So really what happens is when we read in a file, this becomes basically let's call it a list of lines. So each line in the file is a list item inside of this in file variable. That's how the data gets read in. So there's a line. Okay. All right. That's a string. Put in a comma. Okay. Next line. That's a string. Put in a comma. Right. And it just builds a Python list with all this information. Okay. So if we're going to, process that data structure, let's use a for loop. So we're going to use for, and we're going to say for each line in the in file, we're going to do the following. All right. We're going to break each line down, and there's a method for processing text called split, where I take a line of text, I run the split method, it looks for the spaces in the file, right? So, like if I'm looking at, like, for example, Hey Jude, it looks at the word and goes, oh, a space. We'll split it there. It looks for the word. Oh, there's a space. We'll split it there, right? That's basically the process of it. And so I can take all the words in a line, split them with the split method, and then store that as a list of words, right? So the list of lines becomes now a list of words, one line at a time. So I'm going to call a variable words. I'm going to take that line of text that I'm reading in from the file, and I'm going to run the split method on it to split the words up and put them into a Python list. Now I have another data structure that I want to traverse as a loop. So now I'm going to loop through the words, and I'm going to do this. I'm going to say for each word in words. And see, this is where you get kind of clever with this too, right? This holds all the words. So I called it words. And if I want to look at one word, I'll use a variable name called word. And these are arbitrary choices, by the way, but this is not, right? Because that's actually a variable. But for each word inside of words, we are then going to loop. As we're looping, now we're going to use the same technique again. We're going to basically look at the words one at a time, but we're going to also clean them up a little bit in the process. And this is really kind of neat. So another method that you can use, there's a split command, which looks for spaces, but there's also an R strip and an L strip. And I want you to look at how like the data comes in here. If I use spaces to split this stuff into words, well, that's a word, clearly. But then if it finds the next space, then it all of a sudden thinks that this is a word, which it's really not. The comma is not really part of the word, it's punctuation. So enter the R strip command. So if you go R strip, what that will do is it will strip from the right side of the word any characters I designate. And as I look at that Beatles song, I'm noticing there's commas, right? Maybe once in a while, I don't see any periods in this song, but maybe, somewhere there's a period at the end of a sentence. I'm also seeing parentheses and other stuff, but right now let's just focus on commas and periods, and maybe we can get rid of dashes too. So I could do this, and this gets kind of weird. And I don't know if it'll take out the dashes or not, because now I'm thinking that that's not a space, so it might not process it, but we'll find out. But I can put inside of double quotes inside of an R strip command the stuff I want stripped, which includes a period and a comma. So we'll look for those things and get rid of them. And we can experiment with dashes, and we'll see what happens with that. And the other thing I want to do is, because sometimes I'll get like words that start with a capital letter because it's the beginning of the line, and sometimes that word's in the middle of a line and it doesn't start with a capital letter, but I want to consider them all the same word. I'll also run the lower method on it. So in other words, convert everything to lowercase, so we're looking, at apples to apples, basically. Right. So now we've taken the words, gotten rid of the superfluous punctuation at the end, converted it to lowercase, and each word is stored separately. And then I can process that word, right? So I can say, if that word is in the big file, so if it's included in that file, is what I'm going to say. So if it's in counts, then what I'm going to do is I'm going to take counts for that word. So that word's going to become, this is really weird, right? It's going to get placed, that word's going to get placed into the dictionary as a key. And then I'm going to assign a value to that key, which is going to be one greater than whatever it was. So if there was no number in there, like if it's the first time I hit a word, like the first time it runs through to hit the word hey, it'll add that word as a key to the dictionary and then add a one to the value part of it. So I'll have the key will be hey with quotes, then there's a colon, and then there's a number one. The next time it hits the word hey, it won't add the word hey again, but it will add one to the total, right? Uh, right. So that if the word's in there, it'll add one to the total. If the word's not in there, then we do an else, and it just simply sets the counts for the words, the word, the first time to one, right? So this would happen the first time it hits, it would hit the bottom one, and then every other time it would hit the top part of the if, right? And then that's all it's going to take. This is really the processing part of it. This will count all the unique words, just this simple little bit of code. And I want you to think about really not a lot of logic here to make it happen. Very, very elegant, very streamlined. Once you get past this for loop, I would say, don't forget to close your file. Right. We're in read only mode, so it's not really actually a big deal, but it's still good etiquette to run close command on your in file. All right. And then I have this little snippet of text here. I'm just going to paste in and we'll just kind of read it for a moment. All right. So our goal is ultimately to display the count of each unique word. But if you were interested, you just wanted to see what's in the dictionary, like you just want to see what's inside of counts. We can just print counts directly. So here's what I'm going to do. I'm going to do a blank print command to start, and then I'm just going to issue the print command and print count. So I'm going to feed in a file, and then I'm just going to look at the dictionary in its raw form. All right. And I'll feed in Hey Jude. And I don't know if Hey Jude's really maybe the best one to feed in here. Maybe I'll go with one of the others, like, I don't know, She Loves You. That might be a better one, right? Because it doesn't have any dashes in it. No, not too many like apostrophes or anything like that. Yeah, I think this will be a good one. So I'll feed in and notice how it's named. She Loves You. It's in the same folder, so I can call it directly. So let's give it a run and see what happens. I'm going to do a save here, and I'm going to hit the run button. All right, so enter the name of the file. I'm going to say she loves you.txt, right? That really should be in a try except statement, but we're going to type it perfectly. All right. And so here's what it did. It went through, read every individual word that exists in the file and counted it. Do you see how fast it did it? That's like crazy fast, right? And it created a dictionary, right? And notice first word, she loves you. Yeah. Yeah. Right. 29. They say, 29 times. Yeah, they repeat their words a lot in this song for sure. But this is a complete list of all the words inside that song and how many times they occur. Right. Now, what might be better? This is kind of hard to look at, perhaps, right? Like you could argue that's hard to look at. So you might not want to do it that way. And so what I think would be more logical is if we use the loop to process the input and put it into the dictionary in the first place, we could use a loop to process the output as well. And I thought what might be kind of interesting is to use this statement here. And you can output this any way you want. And I'm throwing this in the chat for you guys so you can just copy this approach if you wish. But this approach, the way that this works, this output method is what we call the argument approach to inserting variables. So this is not string interpolation, but I could do this with string interpolation too. And in fact, maybe I'll write it with string interpolation next. This is the older approach, which still works just fine. But basically what this is going to do is it takes whatever the word is, right? And so for each word in count, so for each word, these would be the words. It's going to take the word and put it here as a string, right? And then it's going to take whatever the value for that particular word is. So we call the index, which is the key, is the word, and then it pulls back the value that would go here. So let's run that. You'll see the difference here. So we'll use the same file. She loves you.txt. And then notice now we have a much cleaner looking list. If you wanted to revise this and make it string interpolation, and I would kind of challenge you guys to use both approaches just to practice them, honestly. We would just let's just rewrite it. We would use our F string approach, right? That's what they call it. And then we would first display the word, right? And then if you want, you can put in a colon or whatever. And then you can display the counts word. So basically, I mean, really, it's the same thing. And actually, I'm doing this wrong. All of that goes in curly brackets. I apologize. So the counts square bracket word, and then close the curly bracket. And then I'll run it. You'll see. In fact, I'll just pull this one out for now. Or here, let's just comment it out. So I'll just put in a hash mark there, comment it out. And then let's run it with string interpolation. Same file. She loves you. Oh, no spaces in it. And there you go. Same basic output. If you want, and this is like, you can get really persnickety about this stuff in terms of output. You could put in a couple of tab stops here, right? And run it again. And you'll see how that will kind of clean up the output just a little bit. Yeah, not the prettiest thing in the world, but you know what? You could also use your string formatting commands that we learned to really make columns out of this. So play with it to your heart's content until you get an output that you like. But the point is that once you have this working, I'm really curious to see what it does with Hey Jude. So let's run it with Hey Jude and see what happens there. So hey Jude.txt. Okay, that's pretty interesting. And notice what it does here, right? Words that have parentheses. Yeah, so I would have to do an L strip to get rid of the left parenthesis, an R strip to get rid of the right parenthesis. There's an exclamation mark in there too that I missed. And then the nas. That's pretty hilarious, actually, how those appear. But very, very fun stuff. So if you guys want to try altering that, you can certainly put in an L strip. Like, for example, I can get rid of the exclamation point. What was the other? The right parenthesis. And then I could also chain onto this and where I would normally put it. And you know what? Let's try it. I can do an L strip with quotes and would put in the left parenthesis there and then close that like so. So you can just chain those commands together. And you know what? Let's try it and make sure it works. So let's try it with Hey Jude. So hey Jude.txt and see if it gets rid of some of that. And it did. Notice how like none of these have parentheses in them now. And the word "na" appears 96 times, when you remove the dashes. I'm not really sure why it kept that one like that. So that's kind of weird. But I think otherwise it worked really, really well, right? Even on Hey Jude. So you can do left strip, which is before the word, right strip, which is after the word, and designate what stuff you're stripping away. Pretty interesting. And convert to lowercase and then count all the words. Pretty fun little exercise. That was exercise 8.2. We are now going to do exercise 8.4, and time is quickly slipping through our fingers here, folks. And we're going to implement this really interesting mathematical algorithm. And this is one of those, and so I have my background is Greek, so whenever I see stuff about ancient Greeks and how clever they were, I can't help but have a little feeling of pride behind it. But we're looking at this concept of what prime numbers are. And if you guys know what prime numbers are, those are numbers that are divisible only by themselves and the number one. So, like, unlike like an even number like the number eight, which can be divided by one or two or four or eight, right? And that's a pretty small number. But prime numbers are kind of special ones. Um, and there's methodologies basically for figuring them out. And uh, back in ancient times, this guy named Eratosthenes, right? I'm not even saying it right, um, created this thing called the sieve of Eratosthenes, which is a way for computing prime numbers. And basically, what he did is he made a big list of numbers, right? And then he would go through and say, okay, well, every other one's divisible by two. And then every third one's divisible by three. And every fourth one's divisible by four, right? And he started eliminating them. And then, in other words, he could put in a number and then figure out how many prime numbers there are up until that number. There's a really interesting little, and I'm hoping it's still out there. And the last couple times I checked, it was still there. If I look up the sieve of Eratosthenes, there is a spot um, on Wikipedia where they demonstrate this. And I want you to watch this graphic. First, they take away all the multiples of two. So notice what's happening, right? So all the numbers that are divisible by two are taken off the table. The thing will cycle again, and next it will look at numbers that are divisible by three that already haven't been removed. Some will overlap, like six will overlap, but three and nine won't, right? So here it's just about done with the twos. And then it's going to go to the threes. So watch the process here, right? And the ones that are already selected aren't going to highlight necessarily when it goes through. And then basically the point is that eventually, by doing this process, there's a point you reach at which you've got all the prime numbers up to this number based upon this formula. And you see how it kind of progresses. And I want you to notice it's as it's doing it, it's developing a list of prime numbers. So 2, 3, 5, 7, 11, 13, 19, 23, 29, 31, 37. And these are not numbers you have to memorize, by the way. But I want you to notice how many prime numbers there are as we count up to 120. There's quite a list, right? So these are only numbers that are divisible by one and themselves. And in mathematics, these numbers have kind of a special place. There is a formula for this, right? So if you look at there's kind of a sequence that you follow. But I think this is really interesting too. They give you the pseudocode for figuring it out. So if you wanted to write code for it, and I want you to look at this, right? They talk about inputs, outputs. They create data structures like arrays, right? And then they use for loops and if statements and a for loop inside of an if statement. And they notice the nomenclature here, a set of information, all of the stuff that we're talking about, right? And this is in a pseudocode fashion. And when you start looking at the mathematical formula for it, it kind of breaks down, and it's kind of, I think, always very interesting that we think ancient people were not very smart, but it turns out they were quite smart considering they didn't have all the technology that we have, but they thought about all the same kind of problems that we do. And how much harder it must have been back then to kind of figure this stuff out. All right. So for us to implement the sieve of Eratosthenes, the formulas are actually pretty simple. It's just a matter of getting it all to work as code. So here's what we're going to do. We're going to get a new program going here. Let's do a save as. And this is exercise 8_4 is what this is. All right. I'm going to get rid of all the commenty stuff here. And then I'm going to go ahead, let's zoom a little bit. And we're going to begin with some imports. I'm going to drop these in the chat so you don't have to type them. And yes, there's other ways where you can accomplish some of this stuff. But from the math libraries, we're going to bring in the square root tool, and we're going to bring in the floor tool, which basically takes a floating point number and removes the extra digits after the floating point, after the decimal point. And those are functions that are in the math library. I can't call them directly from Python. I have to import the math library to do it. We are going to prompt the user for a positive integer. And so you can write your prompt any way you will. But when you're grabbing it from the prompt, you do want to convert it to an integer so that we can do math with it. All right. And then what we're going to do is we are going to set up a variable called primes. And yeah, I do have a comment that I put in here that says start with all the numbers from 2 to n. And so here's how it's going to go. I'm going to set up this variable called primes. I'm going to build a set. So if I want to build a set, an empty one, I can just do this command, right? And then that will create an empty set waiting for information. Now remember, what a set looks like in the background is basically curly brackets, and you have a value, a comma, value, a comma, value, a comma, kind of like that. That's a set, right? As opposed to like a key value pair, which was like could be a number and then a string, right? And then a comma and then a key value pair. That's not how sets are put together. Now I can pre-populate this set with information. So for example, if I had a Python list I wanted to feed into it, or I had a series of numbers I wanted to feed into it, I could do that. But a really clever way to populate this list, or excuse me, this set, is to actually use the range command, right? We've used this one before to run loops, if you remember. And the way that the algorithm for determining prime numbers starts is you always start with the number 2. So the first number in the range is going to be 2. And then the top number is going to be 1 beyond the number that the user typed in at the prompt. So that will be n plus 1. So we'll go from 2 to n plus 1. And what this will do is that will basically, so like, for example, in fact, let's just demonstrate it. I can actually print, the primes in the aftermath. So if I run the program as is, and I put in, let's say, the number 5, right? It's going to create a set with 2, 3, 4, 5. And if I run it again and say I want 1,234, there it is, right? So it created a list. And notice how fast it was, right? So this list goes from basically set. I keep saying list, but I mean set. It has all these unique numbers up until the one that I typed, right? So that's kind of how that algorithm works. We're not going to just brute force print it though. So the user will be in control of determining prime numbers up to whatever value they want. Now think about this. In the Wikipedia example, they went up to 120 or something like that. And there was a bunch of prime numbers. I don't know, 20, 30 of them. But this algorithm, basically, if you wanted to type in a number that was like 35 digits long and figure out how many prime numbers there are, it'll do it. It might take a little while to calculate, but it will do it. All right. But let's do the calculation part. And this comes basically from that algorithm that we were seeing on Wikipedia, where we're going to say for I in range, and this is where we're going to loop through the data, and we're going to start at the value of 2. And then the algorithm basically says that we want the square root of the number the person typed in. So here's the thinking. With that sieve of Eratosthenes, right? If I took the square root of 120, right, and then add 1 to it, eliminate all the decimal points, that'll basically tell me how many I'm going to go from 2 up until this number, and then I will have reached all the prime number calculations. So I really don't have to count up to 120. I just have to count up to the square root of that number. And then by that point, I will have calculated all the primes, right? So in order to say that in terms of this, and I don't expect you guys really to kind of wrap your heads around the math. But I am trying to explain it, just in case, I do have a math lead in here. Basically, the formula is going to look like this. So we're going to run the square root of the number the user typed in. We're going to remove the decimal points because there probably are going to be some, unless you put in a perfect square like 9 or 25, right? And then we're going to add 1 to that total because in the range command, we have to go 1 past it, right? So that's the math for running that loop. We don't have to run it all the way up until the number. Then for each iteration, we're going to run another loop. And this time the range, got to type it right though, is once again going to go from 2, but this time to halfway up the numbers. So like if I typed 100, it's going to go up to 50, right? And how do we do that? We take n and we'll do integer division by 2. We're cutting it in half. Right. Now, once again, I'm not going to go into the mathematical proofs for this, but basically every time I do this, it's going to take the 2 numbers. I want you to think about how this is going to work. One is going to run this range command, which is going to go from 2 up until 1 beyond the square root of the number. Like, okay, so I'm not sure what the square root of 121 is, but maybe it's something like 20 or something like that, right? It's not even that high. And so that's going to run one number that we're going to use as a multiplier, right? It's going to go 2, 3, 4, 5. And then on the inside loop, we're going to start at 2, and then we're going to go halfway up to whatever number we've typed in, and then multiply that against it. So really what we're doing is we're running one loop. So first 2 is going to multiply against 2, then against 3, then against 4, until it gets halfway up through n. Then it's going to go to the next number, which is going to be 3, and then start multiplying by 2, by 3, see like the pattern. So we're just kind of working our way through the multiplication tables. And then these weird formulas here are just kind of capping us at a point that we need to reach. That's all we're going to do. Every time we do a multiplication and calculate a number, then we're going to remove that number from the primes list. So we're going to use the discard command. That's a remove command. And what are we removing? I times j, whatever that resolves to. It'll calculate it. If it finds the value in the set, it'll remove it. And then, because if those two numbers multiply together, reach it, it's not prime, right? Because we're not multiplying by 1, right? So that's the algorithm. And I know that's a whole lot of explanation for these formulas, but it is what it is. Right? So when we're all done, we want to display the results, right? Right. And then we're going to just run this very, very simple loop here to do the output. And I want you to notice that I'm throwing a wrinkle in here that we're sorting the primes, right? Because here's one of the aspects of sets. When you put numbers in a set, and the ones that we had here happen to go in order, but we can't guarantee they'll stay in order, right? This is one of the problems with sets. So I'm going to run the sorted command on it to make sure that when we do the output, that the numbers are ordered. And then we'll use the print command and put out the numbers one at a time with spaces in between them. All right, let's run this and I'll show you that it does work. And we'll start with very small numbers. So I'm going to start with the number 5. All right, so the prime numbers less than or equal to 5 are etc. Right, so 1, 2, 3, 2, 3, 4, 5. Right. Another approach, and I want you to think about this, right? If I didn't do this loop, I could just do print primes. So let's run that again. And if I did it that way, let's use a bigger number this time. Let's use the number 8. It'll just print it like this. So, I mean, it doesn't matter which way you print it. Either approach is okay. What I do think is kind of fascinating, though, if I take this and I do start to put some kind of large values in it. So let's run this and okay. Somebody said, why did it print 4? I don't see that it printed. Oh, yeah, that's kind of interesting. That I must have done a mistake in my math here. All right, you guys tell me where the error is in my calculation. Yeah, it should not have printed 4. Isn't it interesting that it didn't do it here, though? Yeah, I think that's really interesting. Interesting. Well, now you got my brain churning on this. So I'm gonna put in it. So if I put in 5, it throws in 4. If I put in 8, well, now it omits it. Why is that? There's got to be some flaw in the logic here. And then if I look at these, and this isn't right either, is it? Right. And I think, all right, let's go back to this approach. And I think that print method is not correct. So if I print this way and I put in 5, okay, it's still putting that number in there. So there's got to be some sort of a flaw in my math here. And then this time it omits it. And I'm wondering if there has to be kind of a minimum number. Yeah, there's got to be some aspect of this I'm screwing up here. And I really don't want to backward engineer the formula. So we're just going to kind of run with it, I think, the way it is. Let me use some larger values. And I think, and I'm going to use what they use 121. And now see, this list looks correct. So there must be something about it using a value. Okay, so if I use 5, it's not working. If I use 8, that's not correct either, right? Because it's including 8 and it shouldn't include 8, is really what the problem is. So there must be some, and I think it might be failing here or here. Maybe we don't need the +1 to include that last number. All right, so now you guys have me like kind of doing the math here. Could put in 5. Yeah, and Kathleen, I think that you're right. It's like something about that. So there's some sort of a flaw here in the logic. All right, but you know what? I don't want to spend the whole night on this, so let's just kind of challenge it a little bit, and then let's use a number that's kind of large, like 1,000. So supposedly that's all the primes up to 1,000, and that looks fairly accurate, without going through each of the numbers. But I think what gets really kind of interesting is if you use a significantly larger number, right? And maybe I'm pushing it a little too far there, but I want you to show you that it will process it. And yes, it's thinking right now. I did press enter, and let's see how long it takes for it to run a number. Let's see, thousands, 123,423,000 and 451. See how many prime numbers come back on this one. So we'll just let it sit for a moment and run. It might seem like it's not doing anything, but I assure you it is. And I don't know if our variable explorer here is kind of keeping track of it. I often do this during class and run one, and then we'd sit there for a bit and think about, okay, all right, this failed, obviously, right? And then all of a sudden, boom, it pops up on the screen. So, what I do think is really fascinating is like we're ready to give up on it because it wasn't instantaneous. But think about all the math it's doing right now. Um, it's running these loops, um, you know, I don't know how many times, hundreds of thousands of times, basically, and it's still doing it, right? And so we are just pushing the technology a little bit further than we might normally. I'm going to let that run in the background, but I'm going to move on to the next exercise in the interest of time, and then eventually this should pop up with data. By the way, so it'd be interesting to see it, like who's gets there first. All right. Next exercise is exercise 810. 810 says the following: write a program that reads two text files and prints out in sorted order all the words that are common to both files. All right. So I'm going to come back here. I'm going to create a new Python file, save as. This is exercise 810. So we'll name it as such, exercise 8_10. Save, zoom in a little bit there. This one here, I am going to run with a main method. And why? Because I did last time, basically. So I'm going to define my main method. I'm going to put in a pass statement for now. And then I'm going to come all the way down to the bottom and make sure I call it so it runs. And then I'm going to make here basically one function inside of here that I'm going to call file words, like so. And once again, I'm going to use a pass statement here until I come up with my logic. All right. The first step is going to be this. I'm going to come up here and I'm going to basically tell it to read into text files and store them in two sets. Okay, so I want you to think about what's going to happen there. If I read in two files into a set, one feature of a set is that you can't have duplicate values. So it's only going to grab unique words. I'll make two variables for this. One is going to be words 1, and the other one's going to be words 2. And then I got to figure out how to populate these. So I'm going to put in equal signs. And then what I'm going to do is I'm not going to do a call to a file here. Instead, I'm going to call my function below, which will read in the files for me and store them, right? So I'm just going to call that function a couple of times. But the function's going to handle all the words, okay, in the files. So down here, why don't we get in here and let's start by read in a file, right? That'll be the first step. Once again, this should probably be in a try except, but in the interest of time, I am not going to run it. So I'm going to say file name equals input, and then we're going to ask for the name of the file. Enter the name of a text file. We're going to grab that. We'll store that in our in file variable or whatever you want to call it. We're going to open the file name, right? This is becoming kind of routine now. We'll do it in read-only mode. We don't want to change the file. Then we're going to create a set to hold the words temporarily inside this function, right? So I'm going to say that create a set to hold the words inside this function. And so I'll just call that, how about words? That sounds pretty good. And we're going to create it as an empty set, right? So nothing's inside of it, but we've declared it as a set. And normally when you see this, this is what we call a constructor function. And when we, next week, we're going to move on to talk about objects and classes in programming. And we will start learning about what a constructor function is, by the way. Next task then is to basically loop through the file line by line, extract each word and add it to the set. And we've kind of done this already. So this is kind of not completely new, but sort of new. So for each line in the in file, we're going to do the following. We're going to split each line into parts. So we're going to separate out all the words, and we'll do that with the line dot split method. Right, so that splits based on the spaces. And then this is now a Python list with all the individual words, right? Then once we have the words in a list, we can loop through those. And so for each word in parts, we're going to do the following. We're going to take the word that we found, and we're going to use the add method to add the word to the set, right? So it's adding the word, and actually this should say to the words set that we created up here. Yeah, so not word, but words. We're adding the word in parts to the set called words, right? That's kind of a mouthful. When those loops are done running, I want you to think what happens. Right? It's only going to grab unique words, loop through all the lines, one word at a time, put them in the set, and then we're all done. And then if we're all done, then it's a good time to close our file. So we're going to say in file close. And then since we're all done processing, we are then going to return the entire set. So this is going to send back not like one piece of information or a number, it's going to send back the whole set of words, however large that is, right? All right, so that's the processing. So this prompts the user for the file name, reads in the file, goes line by line, grabs each word, puts it in a set, right? And notice up here, I call file words, which will do that whole process. So I'll read one file into this variable. I'll read another file into this variable. These variables ultimately will become sets with listings of unique words. Right. I do find it interesting that the console is still running and that it hasn't finished yet. So I'm just kind of waiting for that moment. It's going to pop up. I don't know if anybody else has tried a number that big, but if yours is taking just as long, don't feel bad. All right. The next thing that we're going to do up here in the main program body is now we're going to do a mechanism to figure out which words are common to both files. Now think back to the Kahoot that we did earlier where we talked about this concept of intersection, if you guys remember. And so what we're going to do is we're going to create another variable here. We'll just call it common. I think that makes a whole lot of sense. And we'll take the first set of words and then we'll run the intersection method on it by feeding the other collection of words into it. And then what it's going to do is it's only going to find the words in common and then take those words and put them into a new set called common that'll just have the common words, right? And then here we will then start to display these, and they do want us to do it alphabetically. So let's just do that alphabetically. And then you can, put whatever output you want on the screen any way you want to do it. So I'm going to say this, print the words that are common to both files. And then what I'll do is I'll loop through that list of words and I'll do it like so. We'll say for each word in common is what I want to say. But I'm also thinking about this alphabetical thing. And since I have a sorted command, I'm just going to wrap that around that set of words. So that will just make sure they come out alphabetically. And then I'm just basically going to print. And I'm not really sure why I did it this way. I mean, I was doing basically a space for some reason, and then concatenating the word to it like this. This is how I was doing it in the past. And I suppose it can just be a list of words. And I think I was doing the space just to move it away from the edge of the screen, probably. Now this is ready to run, but I have this problem here that this program is still trying to execute. And I don't know if anybody else tried one that was quite this large, but here's a thing you can do. Like if your console still hasn't responded, And I assure you, this will eventually respond, right? And how do I know that? Because of, I think because of the memory usage that I'm seeing down here is pretty high, considering. Um, but there are ways to stop the kernel from running, right? So the Python kernel is the thing that runs the code, and you can just come up here to the toolbar and hit stop. That's one way to do it. And so I interrupted it. I really kind of didn't want to do that, but I was kind of hoping it would respond by now, but we need to move on. So, all right, I'm going to go ahead and run this program now. And um, and once again, it's going to prompt me twice for a file name, and then it'll tell me the words that are common between the two. Now, I know I have Hey Jude and She Loves You sitting there, and I think Blackbird sitting there too. So I'm going to use those two files to do this. So here comes the runtime, folks. All right, enter the name of a text file. She loves you. .txt. Right. And once again, this should really be in a try catch, but we're not doing that here today. And then we're doing Hey Jude .txt. All right. So these are the words that are common to both files. Now, I do see that it's picking up some punctuation, like yeah with a comma, and I didn't make things lowercase. I could have done that too, right? All that processing that we were doing before. But notice, and yeah, you, your, a, bad, be, can, her, it's, etc. And those are the words that are common. And notice the kind of words they are, right? A lot of them are what we call, like in AI, we call these stop words, right? Really common low level words with really not a lot of substance, the ones that are used a lot. All right. So there's the example of that. You could, of course, verify the results by looking at the files and going, yep, there it is. Yep, there it is. But this is a really kind of fun and simple way. And once again, I want you to look at the amount of code that it really takes to kind of figure that out. It's not really a lot, right? It's not really a lot of code. And I think that's a really big takeaway here. All right. I do know that we're over time. So what I will say to you is if you have somewhere to be or somewhere to do or whatever, you are free to go. I am going to keep recording and record the solution to the next exercise, by the way. The next exercise is exercise 817. And 817 is one that has this kind of doing a little bit of data processing work. And this is kind of interesting because it actually takes a live data set that was captured from the CIA government website, site where they publish information about data about other countries and our country and all that. They have the original URL here. I don't know if this still works, but I did capture the text file quite a long time ago. It is one of the text files that was included with the assignment description, wherever the heck that is, which is this one here. And if you click on it and look inside of it, I want you to notice the kind of data that's here. Basically, what this is a list of I don't know if it's all the countries on the planet. I think so. Yeah, it looks like all the countries on the planet. Um, right. With their rank, right? Okay, what are we ranking? The per capita income for each one of those countries. And and it might come to a surprise to some people that the United States is not at the top of that list. We're pretty far up there, but we're not at the top of the list. In fact, there's a number of countries that individuals, as a societally, earn more money than we do, and you can see some of those here, right? But certainly we're up there, right? And I do find it really fascinating. This is a really, really old data set. So they're saying back in 2004 that the per capita income in the United States is around $48,000 per person. So you take all the income that's made and then you break it down across every man, woman, child, old, young, whatever. And that's how much money on average a person makes, right? And that on average is not the right terminology. That's just what it calculates up to. Doesn't mean that people really make that. Some people make a lot more, some people don't make nearly that much, right? And that's the unfortunate reality. Now, as you look at this information, you will notice, as a text file, and I did grab this text file and I dropped it into my folder here. So I have it here as a raw text file that I can open up inside of Notepad or other text editor. And as I kind of navigate through the file, once again, I'm noticing that this is what I call a tab delimited file, right? So when I jump these big gaps here, it's one single key press to cover that whole distance. Now, this one, for whatever reason, is a bunch of spaces. And then I have like this number, and then there's a comma in the mix, which makes the data messy. But this is probably a dump from some sort of a database or other data file. And basically, we have a ranking, we have a country name that seems to be like these are columns of information, right? So this is like a rank ID or something like that. This is just a country name. And then we have a special symbol and a bunch of spaces, and then we have a number formatted in with commas, not very pretty. But we still can use Python to take a file like this and process the data inside of it, and then not only process the data, but take the data, store it in a data structure, and then set up code that allows a user to basically query that data that we've captured and extract information from it. And so people who are in the AI data analytics program of particular interest to you, because this is the kind of stuff that data people do really do with Python, right? And this is granted a low level example, but not unusual, right? So let's do this one at a time. I'm going to do a whole lot of copy paste here just so we can move kind of quick. And I'll begin by doing a save as here. So let's save as. This is exercise 8_17. Right, zooming in. Also blowing away the given comments here. And then what I'm going to do is I'm going to just put in some information. So this is what the program is going to do. We'll begin by setting up an empty dictionary. So here's the empty dictionary. I'm just going to call it incomes. Then we're going to go ahead and open the file like so, right? I'm just hard coding this one, right? We could prompt the user for the information, but we know what file we have. We know what it's called. So let's just read it in just like that. Then we'll set up a loop. And I'm just going to dump the whole loop in at once here. And once again, I'm doing this in the interest of time because we're over time right now. So for each line in the in file, we are going to take the line and split it. And notice the split criteria here. Notice I'm using an escape sequence. I'm splitting based on the tab returns, right? Or the tabs that are in the file, because those are the separators in the file. So it's a tab delimited file. And so I'm splitting it based on those tabs. Then we're going to remove the $sign and the comma. And notice how we do that every time we loop through, right? Without getting too detailed about this, this piece of information would be in position 0. This piece of information would be in position 1 in a list. And then this, well, actually, with the $sign, is in position 2. This is all one piece of information. That's one piece of information. That's one piece. So all of this gets read into the in file as one string of text inside one Python list item. And then we're going in and we're splitting not all of it, but the third position, and we're removing the $sign and the comma. And the way the code works is when we find the $sign, we place it with a blank, right? And then when we find a comma, replace it with a blank. And so it reads it in first, gets rid of the $sign. It reads it in again, and it gets rid of the comma. And I want you to be mindful of the fact that the split command has already removed all the spaces and ignored the tabs. The tab was a separator, but spaces are automatically removed by the split command. So spaces are gone, tabs are gone, $signs are gone, and commas are gone, all with that code. Pretty elegant, really. Then we're going to take each country that's in that list, right? So we're going to go to the middle position. There's position 0, 1, and 2 for each line. And we're going to take position 1, which is the country name. We're going to convert that to uppercase, right? That's what's going to happen here. but we are going to take whatever this is, and I want you to think about what's happening here. We're taking the dollar value in parts two, which is that's the piece of data in the third position, um, converting it to a floating point number. So it's got decimal places now. And then we're storing it in our incomes dictionary with the country name becoming the key converted to all uppercase. So like Qatar, which is at the top of the list, there would be QATAR, all uppercase letters as the key. And then the floating point version of that um, number is now the value that goes with it. And I want you to be mindful when we read stuff in from a text file like this. This is coming in, like what I have highlighted is coming in as text. It's not coming in as a number. So once we get rid of the dollar sign and the spaces and the comma, and we're left with just a number with no comma in the middle of it, then that can be converted to a floating point number or an integer or whatever. And I don't really know why it has to be floating point here, honestly, but just what we did last time. Right? So that does all of that work. The next aspect is we'll read queries from the user. So now that we have all that information spooled up and stored in a dictionary, we are now going to allow the user to interact with that information. This is where it gets kind of cool, right? So we're going to set up first a while loop, right? And as long as the person doesn't type quit in uppercase letters, we're going to actually do this. We're going to look, what we're expecting the user to do is enter the name of the country, but we're going to look for the name of that country in the dictionary. And if it's found, we'll display the income that goes with it. So here's how we're going to do that. So we're going to say, if the country, and I'm just pasting this in, folks, in the sake of time, if the country is listed inside that dictionary, we're going to look up that country, and this lookup, which finds the country as the key, will bring back the dollar amount, and that'll just say the per capita income is income's country, right? Otherwise, it's just going to tell you it didn't find that country. Check the spelling. Maybe you misspelled Liechtenstein, which is understandable, right? We'll put in a blank line, and then we'll prompt the user again, basically to put in the prompt again and prompt them for another country. So enter another country name or type quit to exit. And keep in mind, they type it uppercase, lowercase, it's going to convert it to upper with the approach that we're using here. Right. And I'm trying to think here. Oh, we missed. Okay, so here's the thing I missed. Right before the while loop, and I'm like, wait, I never did my initial prompt on this. So right above the while loop, so before the while loop starts, we still have to prompt them for the country name. So that's the piece I missed. Prompt for the country name. So as long as they don't type quit, it will look it up, give us the per capita income or an error message, and then ask us again, right? And that's basically the whole program. And then if you want to be polite at the end, you can do what I often do is just give them a little message that just indicates that we're all done, something like this. Okay. I'm going to go ahead and run this just to demonstrate that it does work. So here's the run. All right. So by the time this prompt comes up, it's already read all that data into that dictionary. So now I just have to type the country name correctly. So I'm going to just pick a country that I know how to spell, like China, for example. Per capita income is only $8,400 in 2004. Interesting. How about maybe like Germany, right? A little bit more. Or how about Russia, right? And then I think United States has a space in it, so we'll say United States. Right. And then what was the one at the top of the list was Qatar. And then if I type in some nonsense, and then I can type in quit, and I'm all done. Right. So that's an example of this one working. I know this is a very, very quick example, and I probably would have spent a little bit more time on this if we had more time, but it's a powerful example of being able to take data files, read them in, store them in a data structure, and then write code where the user can extract information. So if you can do that with it, think of all the other types of apps you could load in, or the other types of data you could load in, and then allow the user to interact with that information. And this is just a console program. This could drive a website, this could drive a mobile app, or whatever, right? It's just all a matter of having the data and the logic behind it to do the interface. All right, folks, that is a completion of our exercises for this unit. So this video stops here.